and welcome to Innovate to Build. My name is Philippe Bonneau. I'm working at Greatech as a product marketing manager, and I will be your host today for this session. So I would like to let me very quickly. Okay, perfect. So today we are going to talk about integrated factory modeling and see the convergence of BIM and digital factory. And I have the pleasure to have Daniel Lutz from Autodesk with us today. So Daniel is working as a solution engineer at Autodesk, where he has gained extensive experience in layout and factory planning, mechanical design as well, including data management. And in the context of integrated factory model, the knowledge in the BIM processes and the integration of civil engineering is complementary. So thank you, Daniel, for being there today. Welcome.
Thank you.
So the stage is yours. So you are going to deliver this presentation live, which is very good for all of us. So feel free to share your screen when you are ready.
Okay. So you see my screen all?
Not yet. Let me push a button for you. And now it should be full screen. So I think you are ready to go.
Okay. Then let's go and welcome. And I'm very happy for all participants in this session, Integrated Factory Modeling, the conversion of BIM and digital factory. Then let's go with the first topics. I start with a small overview. And I start with a comment from Frank Weidenbacher from EDAC. He said that construction and applied engineering are two separate worlds that have not really had to be well coordinated up to now. And I'm fully agree with Frank. And that's the reason why we talk about today about the IFM, the integrated factory model. So I start with this small teaser. We see a lot of data today from this video, but I speed up a little bit. The reason is we have a lot of stuff in 30 minutes. So what are our challenges during the day and the whole week? We have new products, we have demand changes, cost reduction, quality initiatives, and changes in the procurement. That means, or for that, we using the integrated factory model for a single fully integrated orchestrated data platform for a continuous interactive implementation and a continuous cycle in the project lifecycle. So we have a lot of participants and stakeholders around the factory model. We have project managers, MEP engineers, suppliers, and so on, and a lot of people for coordination of a factory. And we have a lot of data in the different departments for the supplier, in the manufacturing, and we must organize all the data and the flow of the data. And in the next, normally or in average, we have over 40 apps during the day which we work. And we see here a small overview about industries. We talking about in the automotive industry, in the classic manufacturing, and in the AEC industry about the IFM workflow. So what are our goals? Normally, we know this kind of drawing. We have a lot of layers, we have colors, and it's very hard to understand this kind of drawings, but that is only a little drawing. And by side, we have a lot of more documents like Excel, Word, PowerPoint, or a classic sheet. So, but I want to focus now or today only at the production planning, the technical building equipment, the MEP, and the building. So normally we start with a classic 2D drawing, a DWG, and we have, for example, the environments for each product line. We are work and driveways, and each layout planner planning his layout in this space. And in the end, we are at the MEP drawing. And now we have the same complicated drawing as before. But now I start again with a 2D drawing. It's not wrong to start with 2D, but now I integrate a 3D workspace, not only a 2D. But that's not a function. It's a kind of workflow. It's an idea from my side. And this 2D workspace or 3D workspace is coming from Revit in this case. And in the next step, each layout planner could planning his layout in his workspace. And in the next step, we replace the workspace from the MEP and integrate this MEP data in Inventor with AnyCAD for Revit. And in the end, we integrate the building. And now we have a fully detailed model, a 3D model in Inventor over the whole factory. So again, we start with a complicated 2D drawing, but that's what we need. We need a 3D model, in this case in Navisworks. Now we append all data, engineering data, MEP data, building, and so on. And now we have a nice workflow in the building. And I think you all are agree with me. That's a much better basic for the discussion with the customer, with the supplier, and all participants. So we see much more in this model as in a 2D drawing. So then let's go ahead. Here again, this small video about this data set. Now we start with the layout and MEP, and at the end we have the building. So in the next step, we look a little bit to the software. For the factory design utilities, do you need a product design and manufacturing collection? But today we focus here on the factory design utilities inside from Inventor, from AutoCAD, in Navisworks. And by side, we could using Revit or the AEC collection for to collect all data in the D&M side or the AEC side via Autodesk Docs. And that's another one very important point. We have with AnyCAD in Inventor a lot of capabilities to integrate supplier data from CATIA, from SolidWorks, from Solid Edge, NX, and so on the right side. The internal Autodesk formats like Revit, Fusion, AutoCAD, and so on. And we see here the plugins from the factory design utilities. It's a separate installation in Inventor, AutoCAD architecture or mechanical, and Navisworks. And the most important point is the asset library. We get here asset library, object library out of the box with over 7,000 assets, but we could integrate our own assets. And now in the next point, we take a look of the factory design utility workflows and functionalities. Again, we have here the asset library, and the asset library is available in 2D and AutoCAD and in Inventor. And that's very unique in the market to have to work in 2D or in 3D, and you get an update on the other side. So let's take a look in the functionality in this video. We see here on the right side the asset library, and we place here the 2D blocks, and that's very normal, or I think you are familiar with this kind of blocks. And we place here these blocks on the end of this polyline. But now I'm using a special kind of object that's a chain asset. And I place here this chain asset on the polyline, and the thickness of the line is the width of the conveyors. And now in AutoCAD, I convert this line in different conveyors. We see a blue one and a red one. The blue one is the standard length, the red one is the custom length. And I do the same with a safety fence. And with that, I jump to Inventor. And in Inventor, create automatically 3D assets in the layout. And the reason is we have the same library for 2D and 3D. And in the next step, I go ahead with the 3D assets. I could do the same in 3D. The 2D and 3D workflow, it's not a must, it's a could. If you want to work fully in 3D, you could start in 3D. Or you do all in 2D. That's no problem, that's your choice. So then we see here a sketch line, and I'm using again the chain assets. Again with the conveyors, I select this sketch line, and the system calculates automatically all length of the conveyors and place the 3D conveyors on the sketch line. And again, we see here the standard color on the red one. The red one are the customized lengths of the conveyors. And in the next step, I place a small template with a workbench, a worker, and a box on the bench. Place a machine, but I won't place this machine on the middle of these red conveyors, but it doesn't work. This is the reason I select here the form, the iLogic form, and enable here this connector, and now I have two green connectors and could place this machine correctly in the middle of this conveyor. And you see here in the functionalities, the asset library is like a Lego box. In the next step, I place the walk and driveways. I want to check the place of the display of the machine. And we see here the display is inside the driveway. And with that, I open the iLogic form, turn the machine, and mirror the displays, and now it looks fine. In the next step, I place the safety fences using again here the chain asset and select a sketch line, and in a couple of seconds I have placed all safety fences around my layout. But here I need a door, and for that I delete here this fence and place with the connectors a door. And you see on the left side a little gap, and for closing the gap I open again iLogic form and change the length of these two segments on the right side. And so I could create step by step my layout. Then let's jump to the next. Small summary. We have here in 2D and in 3D the object library, and it's very easy to create layouts step by step based on the library and the connectors. So, and a lot of customers ask me, what must I do to create these all assets? And for that we have 5 steps. At first, we must simplify the models. That means we have on the left side a very detailed machine, a packaging machine. We see this machine before in the video, but this machine has over 7,000 parts with all screws, washers, and holes and little details. And for that, we create a simplified part, very important. It's only a part, and using this part later in the layout. So for the simplification, we are using the simplify option in Inventor. We select here small parts by size, 250 millimeters in XYZ. And we see here now we have unselect over 6,000 parts. And to see all this part, we change the view and remove a couple of parts on the visible side. So if we are finished that, we invert the view again. See here all these parts. Define the remove features, but for that I'm using a preset. I have predefined all these dimensions. And in a couple of minutes, in this case, in 2 minutes, I have only one part without small features and without all small parts. And now I jump into the asset builder. Define in the first step the landing surface. Find insert points. And next, I create an insert point for a connector. I want to add later here on this point a conveyor. And for that, I must define a connector. Directly on this work point, define the direction in X and Y. And we see here now this connector. And in the next step, I define the height and the width of the conveyor. With that, if I place later a conveyor, the conveyor look to the machine and we see here these dimensions. And if I place the conveyor on this point, the conveyor have the correctly height and width. And the last step, I define a layer. This layer is available in 3D and in 2D. And the last point, I need a connector glass. And this connector glass share the data or the parameters between this packaging machine and the conveyor. Okay, now the creation of the assets. That's not easy to explain. We have here a simple part, a simple safety fence with a couple of parameters. I think that's finished in 1 or 2 hours. That's really easy going. But we have here, for example, this door that's hinged on the right, on the left, it's open, it's closed. That's a little bit more workload. It means we have here a couple of more parameters, and I'm using iLogic to programming here this door. And in the next step, for example, I have these conveyors with different display levels. That's more workload. I have here a longer model browser and more rules. And in this case, I must create a separate connector class. That means, or you see here, it's very different how big is the workload to create these assets. And now we see here the asset form from iLogic, but that's very easy to create these forms. But at the end, we have here the level of detail or the level of display, of coarse, of medium, and in the end, to fine for the last presentation in front of the customer. Next step, we have the chain asset. We see it before. Now we have here only a line, could create a thick line in 2D. We could convert this line in separate assets, and we have the same in 3D. And the last step, or one of the last steps, we could create different colors of the connector. That means we have a green default connector. This green default connector is working with all other colors, but in this case, the blue could only work with the blue and not with the red or green. That means you could integrate small rules how we could or what we could connect with the other parts. And in the end, we have the layer management that's based on a simple 2D drawing in AutoCAD, and that's linked as a template in the factory options. So we have this layer in 2D and in 3D, and we could organize all assets, in this case green for machine, blue for transportation, other green for workbenches, orange for robot equipment, red for the safety fences, and we have the same in 2D. And that are the 5 steps to create assets and all capabilities for the assets. And the next, we have the building integration. Before, we had talking only about the factory layout, and now we integrate a building. We see this layout before, and we see it also before we integrate the MEP from Revit and the building from Revit. You could integrate this data with original Revit projects, or we could using IFC. So we start again with this installation space. This installation space is created or defined in Revit, and we could load this Revit data in Inventor. What are the benefits? We see here this installation space in Inventor and the machine or the production line in the middle. And with that, we see here in a very early stages the collision between the machine or the cabin of the machine and the workspace of the MEP. And for that, for a better checking, we replace the workspace with the original data out of Revit. And see here very fast the collision between the ventilation output and the cabin of the machine. So let's jump here in this video. Checking my time. Okay. We see here this separate view in Revit. Go to Inventor. Open this Revit model with the AnyCut for Revit. And place this workflow on the urgent point. You see here again this collision between the machine and the workspace. For double checking this issue, we're using Navisworks and using the clash detected functionality from Navisworks. And in a second, we have here in the view the collision between the MEP and the machine. And how we solve this problem? We are here in Navisworks, select the MEP and the production B. See here this collision. And go to Inventor. We hide the workspace. Go again with any cut to the Revit model and include here this data from Revit. Okay, and now we see here again this collision. I hide the MEP, unhide the workspace, and we see here we have enough space on the left side for moving the machine. And with the factory design utilities and the move option, I select all these assets, go to factory, reposition all data, .5 meters to the left. Unhide the workspace again. It fits well, so it's fine. And looks perfect. Now, I think we have no clash. We go back to Navisworks, run the clash detective again, and we see here this clash with the status resolved. And with that, with all this 3D data, it's very easy to find all these issues. And I think you all agree with me, it's very hard to find this clash on a 2D drawing. So then let's go a little bit to the data exchange. I jump over to the AEC convention for running out of time. And now that's a new functionality from Autodesk. It's the data exchange, and that makes very easy to share the data with the ACC. We see here a few of all available plugins in Inventor, in Revit, in AutoCAD, and so on. And before we see here the import of the Revit data in Inventor, we must open the Revit project. We must select the view, and we could or must select all these categories of the different views. And now, with the data exchange, we could open this very easier connected with the ACC, with the Autodesk Construction Cloud. So we see here the same data and the same workspace or installation space. And for that, the next step, I upload this data to the ACC. And that's the increment of this Revit project. That's only this view. And I could open this view in the cloud. Here, different workspaces. Go into Inventor. And open this workspace on ACC and load this data in my layout. You see in the browser here this model is coming from the cloud, with cloud system. Then I create my layout and using also the data exchange plugin in Inventor and upload my data to the ACC. And now I go back to Revit, and in the first step, to Autodesk Docs, and check the preview of the data in the web. Now we have here the whole bill of material with each machine and have all properties of the machines available. Then back to Revit. And I open here this data exchange coming from Inventor. And now we have here in Revit a fully detailed model. And that's a very easy way to share data between Revit and Inventor. So here we see before we have factory for factory design with Inventor. We could export a Revit project, manage this project in Vault, and upload this data to the ACC. But with the data exchange, we could do this all directly between Revit and Inventor. And in the end, we're coming to the visualization. For example, out of Inventor and Revit, we could upload or add this data in Navisworks. And with the cloud rendering, we get here very easy with a couple of clicks panorama view with the cloud rendering. If you have a smartphone available, please scan here this QR code. And then we get here a very nice panorama. And if you scan this QR code, you have here this nice panorama view. And with that, jump here a little bit. That's VR, AR, and VR in our VR room in Munich. And with that, I'm finished with my presentation, and I open for answers and questions.
Thank you so much, Daniel. It was really very impressive. And, I love to see products in action. So you have shown so many videos, so many ways to use Inventor, Revit, Navisworks, Autodesk Construction Cloud, and many more products altogether. It was really impressive. So thank you for that. We start to get some questions. So guys, don't hesitate to enter your questions in the live chat. We still have 10 minutes to answer what you have in mind. So again, don't be shy and type your questions. I see a question about iLogic, which works with Inventor, right? So there is a question, how can I access iLogic and the iLogic form of one asset, Daniel?
Yeah. Okay. So what's the really questions about the iLogic? I think iLogic is included in Inventor, and you could define rules if the door is open or hinged left or right, or you could create here small rules for height and unheight, couple of parts and so on. I think that's a basic tool for creation the assets, and it's included in Inventor. It's not an add-on, it's out of the box.
Okay, so all Inventor users should access this tool, right?
Yes,
okay.
Yes.
Perfect.
Yeah.
And by the way, I have the same question for Autodesk Docs. How can users access Autodesk Docs? I think it's part of the collection, but maybe you can tell more about that.
Autodesk Docs is available in AEC collections automatically. Or if you're using only the PDMC or not only using the PDMC, you need separate licenses for Autodesk Docs. But in each seat from the AEC collection is one Autodesk Docs account available.
Okay, perfect. And if our attendees want to know more about those solutions, I just share link here, software solutions for BIM and Digital Factory. So the question about iLogic becomes even more precise. How you display the iLogic form for one asset in factory environment. So I don't know if you have the answer to this question, Daniel.
Okay. You see in this form on the right side at the top, you have here the name Factory Design Properties. And you must name your iLogic form in the asset creation Factory Design Properties. And with that name, that's hard-coded. If you're naming the iLogic form with this name, it's automatically available in Inventor.
Okay, excellent. Sounds good. I always love to see how you can simplify your project, in Inventor. So I think you have to go through a few very simple settings, and I think it's based on the dimensions of the parts, right? Maybe you can say a little bit more about that. How you can simplify a part or an entire assembly in Inventor.
If you open a part or like this machine, this packaging machine, you could change the dimension, the length or the height with the direct modeling in Inventor. But I'm sure you're coming on the point to decide it makes no sense to do this based on an imported part. In this case, for example, this conveyors, for example, I create these assets from scratch. If you integrate a lot of dimensions and a lot of capabilities, it makes sense to create these assets from scratch, not based from an imported part. For the safety fence, for example, you could do this with direct modeling. You could stretch the height and the length. That's very easy. But in the next step, with this door, for example, I create this door from scratch. It makes no sense to open a step file or with any cut from another CAD system, and then you create this asset. It's very complicated, or it makes not fun. It's better to create a new part.
Okay, perfect. I have another question which starts with a nice statement. Thank you, Antoine. Thank you very much, Daniel, for this presentation of workflow and 2D and 3D layouts to anticipate planning and rendering, either plants and buildings, so first in factory, either with Inventor, Revit, or Navisworks to propose some beautiful rendering views. So I think everyone enjoyed watching renderings. So it was nice to show how you can create some nice renderings from Navisworks, from all the projects you can have together coming from Inventor, Revit, and many other solutions as well. So I think people love that, and it was great to remind them about this possibility. Another comment from Emzan, informative, thank you, explored with new technology, we would like to learn more in the future. So that's great. People are interested to know more about that. I have a comment in German. So Daniel, if you have access to the live chat, I'm sure you will much better understand that what I will. But it looks like it's a nice comment. So thank you, Jean-Marc. Okay, good feedback so far. So okay, so I just give 1 or 2 minutes to attendees to ask a last question, and I think after we will say thank you to all and end this session. So everyone, if you have a last question for us.
No more questions?
No, I think It
All
was a
right.
very comprehensive presentation, so thank you so much, Daniel. I learned a lot
Thank you.
myself. Very, very nice to see all of that working all together. It looks easy to use, very efficient, and quite impressive, to use BIM and digital processes for a factory. Wow, it's really great. So with that, thank you so much, Daniel, for joining us today for delivering this presentation live. I know it's always a bit challenging to show live, but it's really very useful for our attendees. And talk to you soon. Have a great day, Daniel, and have a great day, all our attendees. It was a pleasure to host this session. Thank you, everyone. Bye bye for now. Bye.
You, and the same from my side, and have a good day, and thank you for participating on my session.
Thank you, Daniel.
Bye bye.
Bye. Bye. Talk to you soon. Bye.